All right, good morning. My name is Dan Friedman. I'm a data center technical solutions architect. I work for Cisco, supporting partners in the Pacific Northwest of the United States. This presentation is an introduction to Nexus Dashboard Services. It serves as a follow-on to the previous presentation I created, which was an introduction to Nexus Dashboard, the platform. So this is all about the applications that basically run on top of the platform. It's suitable for business and technical audiences, so let's go ahead and get started. From an agenda perspective, the Nexus Dashboard services that we're going to talk about are listed here. We've got Nexus Dashboard Fabric Controller, or NDFC. We've got Nexus Dashboard Orchestrator, or NDO. We've got Nexus Dashboard Insights, or NDI, and Nexus Dashboard Data Broker, NDDB. So what exactly is Nexus Dashboard? This is going to be a review, I guess, a very quick review of what the dashboard itself is. It's a platform that runs multiple network operations services or applications that provide network visibility and provisioning capabilities. Day 0 and Day 1 operations are focused on provisioning of new environments, whereas Day 2 operations is focused on visibility and modification of an existing environment. The platform is a combination of hardware and software which provide an environment that's suitable to hosting one or multiple of these network operations and management services. This here is a progressive slide that I'm going to fast forward through. It's from a previous presentation. And in that previous presentation, I dove into the explanations behind this diagram in detail. I'm not going to rehash all of that here. I will just quickly summarize. At the bottom, we have the Nexus Dashboard platform, which consists of physical or virtual compute nodes with a software layer running on top that creates a cluster. This platform provides a single point from which to lifecycle manage the services that are loaded on top, as well as to provide common services and third-party integrations without having to configure those independently on a per services or application basis. In the middle, we have the 4 services that can run on top of the Nexus Dashboard platform and which are the subject of this presentation. So in the left, we see NDDB, which is Nexus Dashboard Data Broker. It's a scalable solution which handles packet capture and deep packet inspection, basically full packet visibility anywhere and everywhere that you need it. Then you've got NDO, which is Nexus Dashboard Orchestrator. This provides multi-site orchestration over ACI fabrics or over NXOS fabrics that are running 2-tier VXLAN EVPN topologies. Next, you've got NDI, which is Nexus Dashboard Insights. This one provides network observability and insights, allowing you to more proactively handle issues that arise in Day 2 operations. And then finally, we've got NDFC, Nexus Dashboard Fabric Controller, and one of its 3 personalities. This allows you to manage LAN, VXLAN, SAN, and or IP fabric for media. SAN controller can be deployed with or without SAN insights. And then finally at the top, we can see multiple different types of sites, all of which can be managed with the services that were just mentioned. The controllers that our services talk to are APIC for ACI fabrics, NDFC for NXOS fabrics, and Cloud APIC for cloud service provider sites. All right, so this here is just a very quick visual of the Nexus Dashboard platform interface. 2 key concepts are shown in the UI example here on the left. You'll see in the menu Sites and Services. When you click Sites on the left, you'll see Sites on the right. Okay, so we're talking about clicking this menu here, and then it pulls up over here on the right, Sites. You can then click the Actions drop-down menu and select Add Site, and you'll see the site type window pop up, and this is where you choose the controller type that Nexus Dashboard Services are going to run on, right? And the controller that the platform or service should talk to in managing that site. So either the APIC, the NDFC/DCNM, or Cloud APIC. And you can see that those selections are available here. This is the APIC, Cloud APIC, and NDFC, or what was DCNM. You'll specify a name for the site, an IP address of the controller, the credentials, and some other settings that I'm not showing here that are still relevant. Once you've added all the sites, you'll want to expand Services menu here and click on Service Catalog to add services. And on this screen, you can basically visit our App Store and lifecycle manage the services that will run on the Nexus Dashboard platform instance. And those services, again, being NDFC, NDO, NDI, and NDDB. So you can install, you can update on the Installed Services tab. You can also restart services. And with each of the services loaded, you can then click into a given service, attach it to a site that you want to manage, and leverage that service to manage the attached site. So, when you go to Installed Services, you'll see tiles there for each of the installed services. You can click the Open button, and it will then take you from this screen that you're seeing up here where it says Nexus Dashboard, and it'll actually take you to Nexus Dashboard Orchestrator, or Nexus Dashboard Fabric Controller, or Nexus Dashboard Insights, or Nexus Dashboard Data Broker. And the menu that you see here along the left is going to change. All right, so now to the specific services. What is NDFC? NDFC stands for Nexus Dashboard Fabric Controller. This product was formerly known as Data Center Network Manager, or DCNM. The last versions of DCNM were in the version 11.x train, and the next versions of DCNM would have been in the version 12 train. But because DCNM was rebranded to NDFC and the versions were maintained, the first version of NDFC is version 12, and we'll just kind of keep on going from there. NDFC has to be deployed in one of three different personalities: Fabric Discovery, Fabric Controller, or SAN Controller. These used to be install time decisions requiring reinstall if you changed your mind later. Today, these are runtime decisions, meaning you can select which mode you want to run in after NDFC has been installed as a service. You can only pick one of the three personalities to run in. If you need more than one personality based on the fabrics that you need to manage, that's okay, but you'll have to install multiple instances of NDFC. Also, multiple NDFC personalities cannot be deployed on the same Nexus Dashboard cluster or platform, so you'll also need to install another Nexus Dashboard cluster. Let's talk about Fabric Discovery, right? This personality is read-only and allows for inventory and monitoring of any onboarded sites and fabrics. Fabric Discovery is good for traditional LAN, VXLAN EVPN, or IP Fabric for Media deployments, which are, those handle broadcast media networks. The Fabric Controller personality is read-write, and it allows for inventory and monitoring of any onboarded sites in Fabric 2, plus provisioning and configuration of the same fabric. Fabric Controller is good for traditional LAN, VXLAN EVPN, or IP Fabric for Media deployments as well. SAN Controller personality is read-write and allows for inventory and monitoring of any onboarded sites and fabrics, plus provisioning and configuration of the same fabric. SAN Controller is good for SAN networks running on NXOS or MDS platforms. SAN Controller can also be deployed with or without SAN Insights. Both Fabric Discovery and Fabric Controller can be used to manage Nexus NXOS traditional deployments or NXOS VXLAN EVPN deployments. Traditional is more like your typical three-tier topology where the individual devices are typically configured via command line interface, but you can also use NDFC to achieve some configuration as well. This is more of a manual process. For example, when you design your network, you must design in you have to design in all of the /30 transit links that connect all your devices together. VXLAN EVPN is a more modern two-tier spine leaf topology, but still running the NXOS operating system rather than the ACI operating system. This is more of an automated process. For example, when you use Nexus Dashboard Fabric Controller templates and automation to deploy a VXLAN EVPN fabric, all of the /30 transit links that connect all your devices together are automatically assigned and configured from a pool of IP addresses that is specified in the template. In an ACI network, the APIC controller manages the ACI fabric. In an NXOS network, the NDFC controller manages the NXOS fabric. Optionally, of course, you can still, use the CLI. NDFC is squarely focused on managing NXOS fabrics, whether traditional or VXLAN EVPN. Okay, you're never going to use NDFC to manage iOS devices or ACI devices. So here's a quick visual of the NDFC interface. When you first log into NDFC, you'll be prompted to configure the personalities that we discussed earlier. And so I'm showing that here on the screen. You've got Fabric Discovery, Fabric Controller, or SAN Controller personalities to choose from, and then various features that you can enable underneath there. These settings also show up under the menu on the left underneath Settings, Feature Management. In terms of the features under a personality, there's a number of different features related to things like Kubernetes, endpoint locator, performance monitoring, VMM visualizer, fabric builder, etc. Once you've got that configured, you're going to want to onboard one or more brownfield or greenfield fabrics. This can be handled under the LAN Fabrics menu. On this screen, you can click Actions and click on Create Fabric. And this brings up a screen that's going to allow you to specify parameters for the fabric on various tabs, which may differ depending on the template type that you've selected for the fabric that you're onboarding. So here you can see general parameters, replication, VPC, protocols, advanced, resources, manageability, bootstrap, and configuration backup. On the Advanced tab, there's a greenfield cleanup option, which is fairly important. And on the Resources tab, you've got all of the IP pools, in particular for those used for the transit network assignments that I mentioned earlier, and so on. Once you've onboarded your fabrics, NDFC will inventory all the nodes in the fabric and populate the switches, policies, interfaces, and services tabs shown on the left as appropriate. You can also view and navigate your fabric using the topology shown on the left. Other important areas of the UI will include Virtual Infrastructure Manager. This is how you add a hypervisor to show hypervisor level network connectivity. LAN credentials, which is how NDFC authenticates to each of your devices. Image management, which is how you manage software on all your fabric switches. License management, which is how you manage licensing on all your fabric switches. Tech support, which is how you gather logs on all your fabric switches, and more. Since NDFC is the new version of DCNM, on this page I've provided a bunch of consolidated notes related to both platforms. That's because for existing DCNM customers, you're eventually going to want to upgrade them to NDFC. When you read the DCNM and NDFC documents, there are a lot of critical data points about compatibility, licensing, minimum versions required for some functionality, etc. I've done my best to try and consolidate all of those into one location here. This isn't meant to be a definitive guide with every answer. In some spots here, I'll refer you off to official specific documents that you should reference. And always reference the official documents, right? But this should be a good summary to kind of keep you on track for most of your pre-sales conversations. So moving on now, what is NDO? NDO stands for Nexus Dashboard Orchestrator. This product was formerly known as Multi-Site Orchestrator, Multi-Site Controller, and Multi-Site Policy Manager, kind of dating way back. The last versions of multi-site orchestrator were in the version 11 train. Sorry, that's incorrect information. That's actually more relevant to DCNM. So I don't have the versions listed here on this slide or in my slide notes, but I think on the next slide, I've got some summary information that will talk about the last versions of MSO and the new versions of NDO. Okay, so multi-site architecture was originally created in order to solve a specific problem, right, that was impossible to resolve with multi-pod architecture. In multi-pod, multiple pods, which are fabrics with separate control plane protocols and failure domain isolation, are managed by the same APIC controller cluster. This means that any tenant policies created in the controller are automatically distributed to both fabrics, regardless of whether or not that's the desired result. Multi-site architecture solved this problem by ensuring that each fabric is also an isolated tenant policy domain. What this means is that all tenant policy is configured within Nexus Dashboard Orchestrator and then selectively distributed to one or multiple sites or fabrics. With that concept understood, this enables certain policies like bridge domains and their associated subnets to be distributed or stretched across multiple sites and fabrics. This means that a single subnet can exist in multiple data centers at the same time, which means that we have successfully extended layer 2 beyond layer 3 boundaries while still maintaining isolated failure domains. This capability is useful in meeting several data center communications requirements, including cold migration, which is where you migrate a shutdown VM from data center 1 to data center 2 without having to change its IP address before bringing it back online, which back in the day, this was a task that VMware SRM, Site Recovery Manager, used to handle via scripted methods. It also handles live migration, which is migrating a running virtual machine from data center 1 to data center 2, also without having to change its IP address, and also clustered solutions. So allowing server 1 in data center 1 to form, let's say, a database cluster with server 2 in data center 2, because typically clusters like these require that the separate nodes are in the same subnet. So now you're able to build clustered solutions across different data centers in the same subnet. These different use cases require different settings on the bridge domains created within Nexus Dashboard Orchestrator, but all of the use cases are possible with multi-site capability. Initially, these capabilities were delivered by Multi-Site Orchestrator for ACI. With Nexus Dashboard Orchestrator, these capabilities are still delivered to ACI, but can also be delivered on NXOS, VXLAN, EVPN deployments, non-traditional deployments. If you're a customer with all ACI data centers, you can use Nexus Dashboard Orchestrator to achieve multi-site capabilities. If you're a customer with all NXOS, VXLAN, EVPN data centers, you can still use NDO to achieve multi-site capabilities. If you're a customer with multiple ACI data centers and multiple NXOS, VXLAN, EVPN data centers, you can use NDO to achieve multi-site capabilities, but with some caveats. You will need one instance of NDO to manage multi-site for all the ACI data centers. You'll need another instance of NDO to manage multi-site for all the NXOS, VXLAN, EVPN data centers. You may need to host the separate instances of NDO on separate Nexus Dashboard clusters. I'm actually unsure of that requirement, so that's something to check into before you do something like this. You cannot deploy the same policies across ACI and NXOS, VXLAN, EVPN networks because they're two different network types, which means you cannot extend layer 2 over layer 3 between an ACI fabric and an NXOS, VXLAN, EVPN fabric. So here's a quick visual of the NDO interface. In the upper right, you'll notice the settings menu. Here you can see the current version of NDO application that's running on the Nexus Dashboard platform. Next, under infrastructure, down in the lower left, notice sites. Remember that sites are added first at a Nexus Dashboard platform level. Only after that has happened can you visit this area in the NDO GUI and tell NDO to attach to one of the sites that's already been added at the platform level. This is what causes a particular site to, quote, come under management of Nexus Dashboard Orchestrator. Next, also under infrastructure menu, you have infra configuration. This is where you configure the multi-site underlay. This has everything to do with running OSPF and MPBGP across your inter-site network so that you can achieve multi-site functionality where desired, like the stretched bridge domains and subnets that we've already discussed. Once that's done, you'll go under application management and set up one or multiple schemas. A schema is really just a container for configuration policies that can then be attached to one or multiple sites that you're managing. Schemas exist so that you can provide some amount of administrative separation for your policies by putting them into different buckets if desired. Then you'll configure tenant and policies, dropping them into one of the schemas you've already created. Tenant policies include things like VRFs, bridge domains, subnets, APs, or application profiles, endpoint groups, contracts, layer 3 outs, and so on. Since Nexus Dashboard Orchestrator is the new version of Multi-Site Orchestrator, on this page I've provided a bunch of consolidated notes related to both platforms. If you're an existing MSO customer, you'll probably want to upgrade to NDO eventually. When you read the MSO and NDO documents, there's a lot of critical data points, again, about compatibility and licensing, minimum versions required for certain functionality, and I've tried my best to consolidate those here into one location. Mostly, there's a lot of notes here about minimum NDO version for certain features or functionality to be achieved. There's also information about the last version of MSO and the first version of NDO. There's also information about which minimum version of NDFC that NDO is compatible with for achieving multi-site functionality across multiple NXOS sites running that 2-tier VXLAN EVPN topology. There's also information about which minimum version of APIC that NDO is compatible with for achieving multi-site functionality across multiple ACI sites. All right, moving on again. What is NDI? NDI stands for Nexus Dashboard Insights. This product is a combination of several former products, including NAE, which is the Network Assurance Engine, NIR, which was Network Insights Resources, and NIA, which was Network Insights Advisor. NDI supports both ACI and NXOS VXLAN EVPN fabrics. In fact, you can support both types of fabrics from a single instance of NDI. Not that this always makes the most sense to do from a Nexus Dashboard platform design perspective. Often, it makes the most sense to host NDI on its own Nexus Dashboard cluster, with that cluster being located locally to the fabric due to the telemetry data that needs to be collected. So before we dive into NDI capabilities, we need to contextualize our conversation a little bit by first understanding the difference between monitoring and observability. If you haven't seen my presentation on full stack observability, I talked about this in detail. Please go watch that presentation and then come back here. But in summary, observability requires far more data collection, analysis, and correlation than monitoring does. The goal of observability is to deeply understand the configuration and operational state of your systems so that you can quickly root cause issues and reduce mean time to resolution. Now, while Nexus Dashboard, and in particular Nexus Dashboard Insights, are not part of the FSO umbrella of products, Nexus Dashboard Insights is squarely focused on providing observability for Cisco network fabrics. All right, so with all of that said, Nexus Dashboard Insights has several capabilities. First, as I mentioned, it collects a lot of telemetry data. Hardware telemetry is data about the status and usage of the hardware, and since we're talking about network hardware, this really boils down to metrics around power, thermals, CPU, RAM, and network. Software telemetry is data about the user consumption or usage of the network. And flow telemetry is data about the actual communications flows occurring across the network. So next, NDI essentially uses AI and ML to learn the typical behavior of your network. It comes to understand over time what normal as a state looks like for your network. And then any deviation from normal is flagged as an anomaly to the administrator so that he or she can investigate it. So for example, if there is a sudden and drastic spike in traffic that doesn't normally occur daily, the administrator is notified. Perhaps a backup job is running in the middle of the day when it's supposed to be running at night. We can raise an anomaly, an alert, and the administrator will discover this and reschedule the backup job. NDI also has a full inventory of hardware that comprises the network and the software that those devices are running. As such, NDI provides advisories, which are context-sensitive information to the equipment that you own and run. For example, it's one thing to get a field notice in your inbox, but you always wind up asking yourself, does this apply to my environment? And if so, where? So that I can go fix things. It's one thing to get a security advisory, but you always wind up asking yourself the same question. In translation, if you have hardware or software that is going end of life or end of sale or has a bug, you want to know about it so you can proactively address the situation. This ensures higher levels of uptime and security for your network and therefore for the business applications running on top of the network. NDI, since it has absorbed the functionality of Network Assurance Engine, now also handles assurance. Assurance is about making sure that the intent of the policies defined by the administrator have been properly implemented and are being properly executed by the network equipment. Essentially, this means, does the intended behavior of the network match the actual behavior of the network? For example, in an ACI network, when you configure a subnet under a bridge domain and the subnet has a checkbox called advertise externally. When you check that box, the intent is to advertise a route for this subnet outside the ACI fabric, allowing external clients to talk to servers on that subnet. However, unless an L3 out is configured and bound to the bridge domain, then no such route advertisement is possible. It's impossible to advertise routes within the ACI fabric to the outside world without an L3 out. If an L3 out exists, even if it exists, if it's not bound to the specific bridge domain in question, then the route cannot be advertised. So in such a case, NDI would discover that the intent advertise externally does not match the reality and raise a red flag to the administrator to correct this. All right, so NDI also handles compliance. Compliance helps administrators establish business policies or rules that the network must adhere to. So for example, when you're working on an ACI network, a VRF has a setting called enforced or unenforced. By default, a VRF is enforced, which means that all the contracts or security associated to endpoint groups that are routed through that VRF routing table are enforced. But what if someone comes along and changes that setting to unenforced? Well, in this case, all of the contracts are configured, but they aren't doing anything because they're not being enforced or evaluated when traffic ingresses or egresses an endpoint group. This can have drastic security consequences because the company which runs the ACI network believes that they are more secure than they realistically are. In this case, NDI can be used to establish a compliance rule that monitors this setting, and if it's ever changed to unenforced, then the administrator will be alerted so that a problem can be fixed. And this also helps with audit, right? In terms of what are your standards and are you living up to them? It's easy for us to be able to tell and answer those types of questions. NDI also handles delta analysis. Delta analysis is how you look at what has changed between 2 points in time. And often this is the first step in trying to troubleshoot a problem, right? Understanding what has changed since some prior point in time when things were known to be working. NDI also handles log collection and connected TAC. Since NDI has a full inventory of all the devices in your ACI and NXOS fabrics, you can collect logs from those devices and leverage them with connected TAC. This means you don't have to upload the documents by hand, which speeds along the operational process, especially when you're troubleshooting a problem. NDI also handles firmware analysis. At some point, you're going to have to make changes to the firmware or software running on your network devices. The reason for these changes are often to gain access to new features in the newer version of software or to patch bugs or security vulnerabilities in the older versions of software. A lot of companies don't perform firmware updates on a regular basis for the same reasons that they don't change their configurations very often. It's a culture of fear. But with firmware analysis, there are a series of pre- and post-checks that are completed to help ensure that a smooth update will occur and to validate that after the update has occurred, all systems are back online and behaving normally. NDI also handles pre-change analysis. So just like we said, a lot of companies live in fear of making firmware or software changes. They also fear making configuration changes to their environment. But change is inevitable. As new sites open or close, as the company scales, as business applications come online or are shut down, as other services come online or are shut down, each of these things requires change. Pre-change analysis allows you to propose changes to your network config and gain an understanding of whether the proposed changes will produce a desired result without breaking anything else. This allows you to make changes to your network with some degree of comfort that you're not going to solve one problem and at the same time introduce 3 new ones. Any alerts that are surfaced by NDI can be exported. Exporting to Kafka allows selective data export to a named topic, which a topic is something that you use in a publisher-subscriber type system so that other systems that need the data can subscribe to that topic and receive it. Data can also be exported to administrators via email. NDI works with NDO, with ACI, and with NDFC for NXOS. NDI integrates with AppDynamics, ServiceNow, and Splunk. Here's a quick piecemeal visual of the NDI interface. You'll notice in the upper right corner the settings menu, which has several submenus. The application submenu allows you to see current version of Nexus Dashboard Insights by looking at About. Run the setup, which is basically the first time setup when you first run NDI. It'll ask you to set up your site groups, which we'll talk about in a second. Download an offline script, which is a Python script that you can run against your fabric for data collection, import, export NDI configurations, and determine status. The site groups menu is one way that allows you to manage all of your site groups. We're going to talk about the next way in just a second. And the integrations menu is where you would handle third-party integrations like ServiceNow, Splunk, Ansible, or Terraform. Then moving to the main menu and top bar shown here on the left. So I'm looking at this area of the diagram. The first thing is to select a site group. Okay, so again, you should have already gone through the basic setup and created some site groups. Now you need to select a site group. So you'll notice right in here, the cursor, my mouse cursor, the little hand. Just to the left of that, you see dcloud-LON, which stands for London. Clicking here will pull up a menu of available site groups, allowing you to choose which site you want to view currently when using the NDI user interface. Just above the mouse cursor, you see the 3-dot ellipsis, which pulls up the submenu that you're seeing below the hand. The Add portion of the menu, of the submenu, pulls up a couple of options that are available when you click on Configure Site Group. So I usually just ignore the Add piece of this menu and click on Configure Site Group. All right, so when you configure Site Group, this brings up the Configure Site Group screen, and you can see all of the subtabs under this menu where you can configure various aspects of how Nexus Dashboard Insights works against that site. Bug Scan allows you to periodically scan your network as new devices get added and old devices get removed to provide context-relevant advisories, things like field notices, end-of-life, end-of-sale notices, PCERT notices for security, and so on. Assurance analysis allows you to periodically take a snapshot of your network and then ensure that the actual state of the network matches the intent. Export data allows you to take the data gathered by Nexus Dashboard Insights from your fabrics and forward relevant alerts via email or make data available via Kafka subscriber-publisher model that we talked about a moment ago. Flows allows you to enable flow telemetry on your network. Microburst allows you to detect microbursts on your fabric. Alert rules allow you to leverage match criteria against alerts to automatically adjust the anomaly score. Compliance requirement allows you to set up rules to ensure your fabric configuration stays compliant with business requirements and regulations, alerting you when the fabric falls out of compliance so you can fix it immediately. And collection status indicates various types of data collection that Nexus Dashboard Insights wants to perform against your fabric, which types are compatible and which are enabled and successful. On the left, we can see several other critical menus and features of Nexus Dashboard Insights. Under Analyze Alerts, you'll see anomalies and advisories. We've sort of already talked a little bit about each of these. An anomaly is any behavior which deviates from a baseline. Again, essentially, NDI learns your network behavior, understands normal, and then alerts you when abnormal things happen so you can investigate them before you start receiving phone calls. An advisory is context-sensitive information about field notices, end-of-life, end-of-sale notices, PCERT security notices, and more that apply directly to the equipment that you own so that you can investigate any remediation actions that might be needed, or proactive hardware replacement, etc. Under Troubleshoot, you see Delta Analysis and Log Collector. So again, Delta Analysis is the ability to understand what changed when you're asked to undergo a troubleshooting exercise. It allows you to compare 2 points in time to understand what changed to assist in your troubleshooting effort. And Log Collector is a way of collecting tech support information from your fabric devices and providing it to Cisco TAC. Under Change Management, you see Firmware Update Analysis and Pre-Change Analysis, which we've already talked about. These features speak to the idea that your network is going to evolve over time, both in terms of the firmware and software that runs on the fabric switches, and in terms of the configuration running on those switches, which determines your forwarding behavior. These features help give customers a better sense of comfort around making operational changes to their networks so that they don't become paralyzed with fear, allowing their networks to become outdated, more vulnerable, and more likely to endure outages. Finally, there's other areas of the UI that we didn't cover. Those are shown by the red arrows. Explore allows you to understand how various logical objects in your system are related or connected to each other using natural language queries. Nodes allows you to view your fabric from a node perspective, which nodes have the most alerts, critical, major, minor, warning, informational, and anomalies so that you can address them first. Browse allows you to view your fabric from many different perspectives, including resource utilization, environmental, endpoints, applications, interfaces, protocols, etc. All right, so since Nexus Dashboard Insights is like the new version of the application service engine and Nexus Insights, you'll probably want to upgrade to Nexus Dashboard Insights eventually. When you read the NDI documents, there's a lot of critical data points about about compatibility, licensing, minimum versions required for some functionality, etc. And I've done my best to consolidate those into one location here. All right, so getting towards the end of our presentation here, what is Nexus Dashboard Data Broker? This product is a rebranding of the former Nexus Data Broker because it now runs on Nexus Dashboard as indicated in the new name. And it's exactly what it sounds like. It's a data broker. This means that Nexus Dashboard Data Broker doesn't process any packets on its own. Instead, it facilitates packet processing by other systems. Back in the day, if you wanted to capture traffic for troubleshooting purposes, you had to log into a network device and manually configure a span session. So I've thrown up some commands here in white on the left that may look familiar, right? You've got monitor session 1, source interface, the interface name, or it could also have been a source VLAN if you weren't just trying to capture traffic from a single server. And then the second command, monitor session 1, destination interface, and a separate interface that would normally be connected to a laptop. When you think about that configuration, it doesn't really scale well to manually visit each switch to set up a span session. Now, all of that work is done for you by Nexus Dashboard Data Broker Controller software. Using the software, you now configure policies which dictate which source ports on which device within which fabric, and which dictate which destination ports on which device within the fabric. You connect these elements together into what amounts to a much more scalable solution. Also, it's more performant because with the variety of hardware devices which can be used to form the Nexus Data Broker network, we can support anything from 1 gig up to 400 gig. With regards to packet capture, it's pretty simple to understand how Nexus Dashboard Data Broker works. The production network is where your business applications run. A production network is the ultimate source of traffic, whether that come from span sessions or physical tap devices. The production network supports many different span and tap sources of traffic. The Nexus Dashboard Data Broker Controller software will program ports on the production network that connect to the Nexus Data Broker network. The Nexus Data Broker network is where you copy production traffic to for brokering or for handling. A Nexus Data Broker network are a series of devices that are programmed by the Nexus Dashboard Data Controller software to copy, filter, and forward packets. The Nexus Data Broker network supports many different speeds and feeds to accommodate the needs of traffic coming from the production network. The Nexus Data Broker network is responsible for copying, filtering, and forwarding interesting traffic to different monitoring tools. The Nexus Dashboard Data Broker Controller software will program ports on the Nexus Data Broker network that receive traffic from the production network. These are known as input ports. And then we have monitoring tools. This is where traffic is ultimately forwarded to. Monitoring tools are those which perform packet processing, such as packet capture or deep packet inspection. The monitoring tools can be used for monitoring how much of total traffic is TCP versus UDP based, IDS, IPS, security vulnerabilities in the Layer 7 payload, web filtering for filtering outbound traffic per business policy, and so on. The Nexus Dashboard Data Broker Controller software will also program ports on the Nexus Data Broker network that send traffic to the management or monitoring tools. These are known as management tool or monitoring tool ports. With regards to deep packet inspection, it's also pretty simple to understand how Nexus Dashboard Data Broker works. This purpose is mainly used near the perimeter of a network. Imagine between your perimeter firewall and internet routers, you have a pair of Nexus 3K switches. In that case, Nexus Dashboard Data Broker Controller software can match and intercept traffic, then redirect it to one or multiple tools in series. A typical inbound traffic use case would be to match all traffic and redirect it to an IPS device, which would perform deep packet inspection on the traffic and then make policy drop decisions. A typical outbound traffic use case would be to match interesting traffic and redirect it to a web filter device, which would perform deep packet inspection on the traffic and then also make policy drop decisions. Unfortunately, no Nexus Dashboard Data Broker interface was available for me to get familiar with in dCloud, nor is it available elsewhere internal to Cisco for me to be able to provide screenshots of the user interface like I've already done for the other services. Instead, here we'll just talk about the service capabilities, architecture, and vocabulary surrounding the architecture so that you'll find in the product documentation. So first, the vocabulary. A tap is a physical device that sits in line between two other devices, thereby receiving all of the traffic on its network ports. It then makes a copy of the traffic it has received and sends it out its mirror port or tap port towards the Nexus Data Broker network. In this diagram, the tap device isn't shown, but its location is where the red arrow points to. We'll discuss this a bit more on the next slide. A span port is a physical port on a switch which receives a copy of traffic from a source interface or VLAN on the switch and sends it towards the Nexus data broker network. In this diagram, you can see the span ports where the red arrows are pointing. An input port is a physical port on a Nexus data broker device which receives traffic from either a tap or a span port. A port group, which is a logical construct and therefore not shown in the diagram, is a collection of tap or span ports which are treated together as a group from a policy perspective. A monitor tool port group, which is another logical construct and not shown in the physical diagram, is a collection of monitor tool ports which are treated together as a group from a policy perspective. A monitor tool port is a physical port on a Nexus data broker device which sends traffic to a monitoring device or tool. And finally, a connection is a logical binding of an input port or port group as the source of traffic with a monitor tool or monitor tool port group as the destination of traffic. This is just trying to stitch the source port to the destination port. The mechanism used for this is layer 2 port-based access control lists. The Nexus data broker network doesn't even really look at the layer 2 header of the source traffic, so it's not layer 2 switching or layer 3 routing the traffic between source and destination ports. In fact, the layer 2 functionality inside of the Nexus data broker network is sort of dumbed down. It's more like a bunch of hub ports than a switch port. So the result of all of this is that configuration allows basically any combination of sources to send traffic to any combination of destinations. You can send traffic from one source to one destination, from many sources to one destination, from one source to many destinations, or from many sources to many destinations. All right, so now to the service capabilities and architecture. We kind of covered a summary of this already, but I want to go into a bit more detail. All right, so on the left, in blue, we have the production network, which can consist of ACI, Nexus, or Catalyst switches. Notice the label at the bottom, Source Enterprise Switches. In the middle, in green, we depict the Nexus Dashboard Data Broker Network, or what we refer to as the Data Broker Network, or NDB network. It depicts a bit more than that, but we'll discuss that in a moment. On the right, in orange, since we're talking about packet capture, we have the management or monitoring or analytics tools that look at the traffic we've captured. These tools address traffic monitoring, visibility, security, troubleshooting, and compliance needs. What we really have here then is a source of traffic on the left in blue in the production network, a packet broker network in the middle of green in the middle in green, which copies, filters, and forwards traffic, and then a destination for traffic on the right in orange, which are the tools. All right, so back to the middle section shown in green, I said that this depicted the Nexus Data Broker Network, but really a bit more. So what did I mean by that? First, we have the Nexus Dashboard Data Broker Controller. This is not actually a part of, nor does it typically reside inside the Nexus Data Broker Network. It's a service that runs on the Nexus Dashboard platform, which might typically be located on a network or, a subnet inside your out-of-band management network. So what is the job of the Nexus Dashboard Data Broker Controller? Its job is to configure Nexus Data Broker devices that are inside the Nexus Data Broker Network, and to also talk to fabric controllers for the fabrics which you want to capture traffic from. Those controllers can be APIC for ACI fabrics or DNAC for enterprise networks. NDFC is not currently supported. Now, if we want to copy traffic off the production network and send it to some monitoring tools, we can do that in two ways. One, span ports, which you can see these shown as the small gray and black circles, which are intended to represent leaf switch ports on the fabric, and then 2 tap ports, which you can see these shown as small orange circles, which are intended to represent tap ports on a tap device. The idea behind the Nexus dashboard data broker controller talking to the fabric controllers is you don't have to log into each individual leaf switch to configure a span session, or even into the tap devices to configure a tap port. Instead, all of this is done centrally through the Nexus dashboard data broker controller, and the controller configures the ports on the production network that will act as a source of traffic to be sent to the Nexus data broker network. In other words, the controller can configure production fabric span ports or tap ports on the Nexus 3550F L1 tap switch as source ports of traffic that we want to capture without directly manipulating the configuration of the production fabric. The idea behind the Nexus dashboard data broker controller talking to the Nexus data broker devices is that you don't have to log into each individual Nexus data broker device to configure the input ports which receive traffic from the production network span or tap ports. Instead, all of this is done centrally through the controller. The controller configures the ports on the Nexus data broker network that will act as a destination of traffic to be received on the Nexus data broker network. Another idea behind the controller talking to the Nexus data broker devices is that you don't have to log into each individual device to configure the output or monitoring tool ports, which send traffic to the monitoring tools. Instead, all of that is still done centrally through the controller. The controller configures the ports on the Nexus data broker network that will act as a source of traffic to be sent to the monitoring tools. Finally, the Nexus dashboard data broker controller bridges the input ports and the monitoring tool ports together by configuring a connection which joins the two without having to log into each individual Nexus data broker device to accomplish this. Instead, all of this is done centrally through the controller. The controller configures the connection session on the source switch and the destination switch. Finally, I want to point out that in this use case, under Tools, we see IDS. This is not IPS. That's because IDS is more of a monitoring tool. It receives traffic and either takes reactive action against another piece of equipment or simply sends an alert. In contrast, you'll notice IPS is used for the other use case depicted on the next slide. Before we get started with this slide, let's remember that the other use case of Nexus Dashboard Data Broker is deep packet inspection. We still have the production network on the left and the Nexus Data Broker network in the middle, but now we have an external connection on the right instead of tools. To illustrate the use case, I want you to think about the perimeter of your network, your internal edge switches and perimeter firewalls on your production network, and your internet switches, packet broker network, and your internet routers, the external connection. In this use case, you would use the Nexus Dashboard Data Broker controller to program the internet switches, probably a set of Nexus 3Ks. What this programming would do is to selectively match some or all traffic, then redirect inbound or outbound flows through one or multiple service nodes. For an inbound flow, you might redirect all traffic to IPS, which does deep packet inspection on the payload, detects a vulnerability, then decides to drop the traffic. For an outbound flow, you might redirect all traffic to the web filter, which does deep packet inspection on the payload, detects traffic destined to a website URL within a category of sites that are blocked by corporate policy, then decides to drop the traffic. In this case, I just wanted to point out that IPS is used, not IDS, because IPS allows for active session policy drops in real time, rather than IDS, which is more of a reactive monitoring and alerting tool. All right, since Nexus Dashboard Data Broker is the new version of Nexus Data Broker, you'll want to upgrade them to Nexus Dashboard Data Broker eventually. When you read the Nexus Dashboard Data Broker documents, there's a lot of critical data points about compatibility, licensing, minimum versions required for some functionality, etc. I've done my best here to consolidate those into one location. I've also added some definitions around vocabulary, many of which we've already covered in the course of this presentation, and which you'll find while reading the product documentation. All right, so to wrap up, I'll just point you at the location where you can find all of the pertinent documentation needed for each one of the services. You can download the presentation, come to this slide. Each one has a clickable link, and there's multiple documents underneath each link. You've got at a glance, release notes, deployment and design guides, user guides, and so on and so forth. So plenty of resources, lots of documentation, lots of detail. Again, that was part of the point of this presentation, was to try and consolidate that all down and give you a good taste of what each one of these services can do, and some basics around the most significant pieces of the UI that you'll be visiting when you're trying to configure the solution. With that said, I want to thank you for watching this presentation. I hope that you found it helpful.